Well, we've got the drainage all in place now around the foundation, and with me to talk about drainage is Phil George from Avanti Construction. How you doing, Phil?
Very, very well, Sheldon.
I see you're on the shovel this morning. It's always nice to see the boss there. Listen, tell me about perimeter drainage.
All right. Perimeter drainage is a very important item to go into a home. First of all, it keeps the basements dry. And it takes basically what it does, it takes the water that runs underground from the rain that goes into the ground.
So we know that as groundwater.
Exactly.
Okay, now groundwater is the water table running along the hard pan in most cases?
Exactly.
Okay, then from that point though, you know, you can do this to an old home, you can do it, this is a new restoration job.
Absolutely. If we were to do this to an existing home, of course, we'd have to do a very large dig, as this is almost an 8-foot basement. But it gets done on a regular basis to keep the basements dry.
Pretty costly stuff on a restoration job, or at least a repair job.
Absolutely. If you were to do this to an older home, you'd probably be looking at about $15,000 to $20,000 to do a renovation of an existing...
Well, that's a lot of hand digging, too, because you're dealing with mature landscaping, concrete, and all the rest of it.
Exactly.
But in this here being a new foundation that's being prepared for the old home to come down on top of it, it's basically a new project.
Absolutely.
Now, tell me about the excavation and also the placement of the drainage system.
All right. Once the concrete has been placed in the foundation and it's been stripped and everything, and of course the proper application of the water penetration has been applied, we start at the highest point of the foundation. So first of all, we have to locate the sump at the lowest level before it just goes on out to the sewer hookup.
And the sump is the outfall to the storm sewer?
Exactly. Once we have that established, then we go to the opposite side of the house, which in this particular case is right here, which would be the highest point. And we have to determine that even at the highest point, the top of the pipe is lower than the finished floor elevation on the inside.
Right, and that's to obviously take the water away.
Exactly. So once we establish that, we go ahead and lay our pipe, and then on top of that pipe, of course, we lay the gravel.
Hey, this gravel here, I notice that you're using crushed gravel in this process, but on the other hand, you see a lot of round rock, the drain rock. Why is that?
Round rock was used up until, you know, the early mid-70s. There's no really difference as far as the drainage is concerned. The best thing for this particular gravel, which is it's a easement of workability.
You can shovel it.
You can shovel it a lot easier than the drain rock, what we used to call the round rock.
The round rock, where you go in with a shovel, and that's as far as you go.
Absolutely. This is a lot easier, and it still works 100% for the drainage ability of the system.
So therefore, establish the high side. You take the measurement from the top of the foundation down to the bottom or the top of the drainage?
To the bottom of the drainage.
And that's where the water line is going to be, then from that point, taking the fall to the sump.
Absolutely.
What about this piece, the vertical?
This piece is a clean out, and we utilize this to of course, clean out the drainage system into the future. What's going to happen to this home is, of course, it's going to be backfilled. It's going to have plants around it. It's going to have, you know, the water that is going to filter through the ground and eventually get in there. It's going to take some sediment down there. So every second year, every 2 years, the system needs to be flushed out. And we utilize these clean outs that we install at the corners of the home to flush the system out and clean it to make sure it's in working condition.
And whereas down the road many years from now, they can always send down, say, a drain snake, that sort of clean-out system, or a high-pressure water.
Absolutely.
Great.
Absolutely.
Well, I want to move along here down the side. Now, here we are here, Phil, at the level of the pipe, and here's a cut of the pipe here. Now, I see this got the holes, and these are the drainage holes, the perforations in the pipe.
Yes.
Now, where do you place that?
Okay, these holes go in the absolute bottom. I don't know if you can see these holes here. We put this bottom of the pipe down to the bottom, and the holes here are for the gravity water that runs underground, that's constantly running, to get into the pipe, and then of course run in this cavity here down to the sump.
So therefore, the bottom curve here is what's going to run the water to the sump.
Absolutely.
How do you know you get the holes in the bottom? There's a simple question.
Well, you know, of course, we have to look for them, but generally when we're installing this, is the numbers and the paint and that's on the top is the absolute top of the pipe, so we just follow that, as you can see here.
So when you see the printing on the pipe here,
exactly,
then I should be able to find the holes, and down there they are, right here. So the holes being there are going to pick up the groundwater coming in, and then on into the system, into the fall of the pipe, and on into the sump.
Absolutely.
Let's take a look at the sump.
Let's do that.
Well, Phil, now we've got the two lines going into the sump. Why the 45-degree elbows rather than just straight 90s?
Very, very simply, Shell, it is so that for the simplicity of cleaning out the system later on, 2, 3 years, 5 years down the road, and if the client, the customer needs to have the system cleaned out, then any type of equipment we send down there,
be it high-pressure water or an auger or whatever, will go around the 45s much easier than a 90.
Absolutely.
Now, 45s, 90s, white pipe, what is the difference? I see you're using white PVC pipe here.
The reason is very simply, again, this pipe, when we put the grade on this thing, which is very important, keeps a steady incline towards the sump. The black flexible pipe quite often becomes like a snake underground.
Oh, so you could have some low areas.
Absolutely, and it traps water in there.
So it takes more time to install, obviously, as well, just to make sure that that's all in place.
Absolutely.
Now, once that goes into the sump, the level that it goes into the sump and exit the sump, there's a difference. I can see it in the pipe.
Difference of about 3 inches. The pipes coming in are higher by 3 inches of the solid pipe going on to the city storm sewer connection.
Now, the sump itself, how much deeper is it than where you can see the pipes going in here?
The bottom of this sump where the water comes up to here is about 18 inches. In fact, it is 18 inches to the bottom of this pipe.
So that's the sediment area for any residual like sand or dirt or anything in the system goes to the bottom, which can be cleaned out from the top.
Absolutely.
Great. Great system. You did a super job.
Thank you.
You bet. Well, folks, back a few episodes ago, as you recall, we're tearing down the chimney, and here's Lauren from Father and Sons. What's he up to? He's just cleaning things because the chimney is on its way up. Hey, how you doing, Lauren?
Hey, Shell, how you doing?
I tell you, not so bad. It's a little bit chilly today, but nice and bright, though, isn't it?
Brought the sunshine with you again.
What are you up to down here? I see you got a saw curve from the bottom of the chimney.
Well, Shell, what we're doing here is we're going to have a flashing that will come in here over the masonry, over the footing, and over the ICS system.
Oh, hey, that's great. That way there's not going to be any water penetration whatsoever.
Exactly.
Well, this busy site around here, I'll tell you today that things are really happening. As you're coming up the brick, and I want to add that those bricks cleaned up just great.
Oh, yes, every brick that's in here is out of the old house. There's not one other brick in it.
Now listen, I understand though, father and son, you also had mother and daughter involved.
Yes, sir.
Okay, well, we got to kind of add those in there. But also up the top here, you're getting into the actual slope portion of the chimney.
Right. What we've done here is generally on a chimney on the shoulder, it corbels like a stairwell, and it's a potential leak area. So
where they're corbelling, where you get that stepping.
Exactly, okay. So the water can sit on there and wick its way through.
Right.
So what we've done to stop that problem is we form it in with forms with an overhang on either side of the masonry. So when the water comes off, it has a rain drip edge, and then there's no worries about the water traveling.
Well, let's take these off right now then, eh?
Yeah.
Take them off and see how things are looking. Now on up to the top, where we get into the actual chimney topping, in the corbelling there, it's going to be kind of unique, is it not?
Yeah, we're going to do a special top on this to accommodate the liner system that's going in there.
Ah, the liner for the gas insert.
Exactly.
Hey, listen, we better get inside and see what's going on inside.
All right.
All right. Hey, John, how are you doing?
Hi, Joe.
I see they let you out of the Kirby Fireplace shop today, eh?
They did, sir.
Listen, this heritage home is something else, but this is quite interesting what we're doing today, putting a Valor, well, it's not really an insert. This is actually a direct vent fireplace.
That's correct.
Natural gas into a brick housing that we have now built out of the old brick chimney.
We'd normally see this, Shell. We'd normally see this into a framework construction, but in this particular case, we're trying to retain the heritage home look. So in this case, you've got your masons to build a nice chimney for us.
Right. Now tell me about the vent pipe here.
What we've got here, we've got the air intake coming into the unit because the unit is a sealed combustion chamber, so it's drawing no air from the room at all.
So normally this would be the type of fireplace that would go direct vent straight out through the wall.
That's correct.
And because of the chimney, we want it to be kept, well, what's that period?
Visually, it's very nice on the outside of this building, so we're going to put the termination at the top of the chimney.
Yeah.
What we're going to do, Shell, we're going to connect our fresh air here.
Now that's fresh air.
That's fresh air for combustion. Here we've clearly marked the liner with
exhaust.
tape for exhaust. We don't want to mix them up when we get to the top of the chimney.
Okay.
And this is going to be secured here with a couple of screws.
And then that goes up the chimney, it rose.
We're going to pull the liners back at the top of the chimney.
Right.
Then when we get to the top of the chimney, the masons have already set a flashing in place for us.
Now this is the chimney cap then.
And this will be the chimney cap. Now, because of the nature of the cap, it won't really suit the building. Our masons will be building a corbel in brick
So that the corbelling is the brick that's going to be built up around this.
Around this, but at the same time, there will be enough air passing through with the design that we've created to form enough air to go into the unit and the exhaust to get out of the cavity.
Hey, now that's exciting. So we'll have actually, I guess, some soldier type of brick here, the stand up on the end brick with the cap on top.
That's correct.
Great. Now, what about the inside of the chimney back when this was a heritage wood burner? Obviously, there was a flue, so we didn't really need a flue in this case.
Then there was a liner in those days, Shell, but in this particular case, we do have to have the 2 liners going down. The old way, we could have put a single liner up, but this is the best way to go.
Right, so therefore no flue liner because there's absolutely no requirement for any wood burning. It's going to be all lined with the aluminum piping that you have here now. And then very simply by turning this around, and this is going to be going back into the cavity. This little unit here, it must be really a hard, almost a workhorse to put out heat.
This is one of the best workhorses Valor's ever made. This is this will do about 800 to 900 square feet.
Wow.
Comfortable.
Heat this room here and the lower floor quite nicely.
And it's also built with a modulating thermostat, and what it does, it senses room temperature. And any change in the temperature, the burner will go the opposite direction. So if it gets too hot, the room will cool down.
I wish it was on today. It would be a little warmer in here.
It would be perfect today.
Well, it's just ideal. I can't wait to see this all framed up with the mantle and the tile around it. It's going to look great.
That's when it looks its best.
Thanks very much, John.
Thanks, Shell.
Well, how are you doing, John?
Hi, Shell.
I'll tell you, when it comes to K&H engineering, have you run into one like this before?
I haven't seen anything like this recently.
Well, this is what you call really an old heritage house, but it's almost like barn construction. I notice you're measuring there. There's absolutely no lintel whatsoever over that window.
That's right, Shell. They have these bearing walls that have no headers. They must just deflect under the snow loads in the winter.
Well, I guess really the old building has just been kind of moving on its own, eh?
That's right.
But, you know, really, when we tore the inside walls out of this building, and a lot of shiplap was in the building with the drywall nailed over top, I guess, over the years upgrading and renovating. But the building on the outside, it's all shiplap, anywhere from 1x6 to 1x8, and there's even 1x10 in some areas. But that really gives the building that structure, doesn't it?
Well, it has a little bit of flexibility to move, but it's still rigid in the nailed planks on every stud.
Now, being an engineer, when it comes to a project like this, really what role do you play?
We're like liability insurance that we carry, and we check the people's work, the framers, and the electricians are drilling holes where they shouldn't be and stuff like that.
So therefore, you're going to, for this project, you're going to tell us what we have to do in order now to bring this up to the code of the day and make the building structurally sound.
That's right, because when this building was built, they didn't have building codes. They just put it together with whatever material they had.
Well, I can tell you one thing. They didn't have a tape measure because there's hardly a stud at the same center. It runs into corners and just, well, actually, it's really hilarious in a sense. But look at here. On the exterior, they put the paper on first, then they put the shiplap in behind or on the outside. But look at the moisture marks here where the moisture has been just moving out with the forced air heating system in the old building and even staining the paper. But, you know, today, in order to the restoration, you have to strip a building out, don't you?
That's right. It's best for, you know, your future environment living in the building. You don't want to have the old rotted paper and stuff in your walls.
You don't want any of that mold or anything of that nature. In the corner here, I thought it was quite interesting. Quite interesting the way they did block their corner, which is very common today, but there's still one stud missing there. But the dimensional lumber, quite a difference in the grading of the day.
It was probably first growth lumber compared to today, which might be a second growth, and the lines, the grade of the lumber is all tighter.
Look at here.
There's a solid 1.5 by 4.
Not a piece of material, or at least not a piece of material that's got a knot in it at least.
That's right.
Now this is quite interesting here over next to the windows here. The old sash balances there on the cords, but look at the distance between the actual frame of the window and the stud wall.
Well, I like this practice here too. It's probably an opening a different size, and they changed their window size and just filled in their framing at one point. There's no header over here, but it has floor joists and roof rafters on it. So when there's snow on the roof, this just must sag and put a lot of pressure on the windows.
Well, I see this is quite interesting here, where they've actually taken the upper ceiling joist and increased the dimension here in order to put a floor upstairs for that second level. But they've actually cut this piece of tubulate down to the point now it's about 2 inches, and the structural point is, again, no header or no lintel carrier whatsoever.
That's right.
So it's really interesting in order to pull this apart and find out this exactly where the problems may be down the road. But can you imagine anybody living in a building like this?
Well, I wouldn't want to live here, but once we finish the work here, it'll be a great place to live.
It'll be the best, good, better, best. Now, obviously here, this has been a door at one time.
Yeah, it looks like this was an old door, and they used some lumber from the shed out back to fill it in and move the door and window over here.
They've just taken whatever lumber that has been made, well, I guess, available out in the barn, possibly.
That's right.
But here's 3 pieces in order to make up, and this one here, it's well, it's got some rot in it, but certainly it looks to me as though it might have been the part of an old feeder pen or something out in the barn.
That or a fence.
Golly, I tell you. Well, listen, let's take a look at another corner of the building here I want you to see.
All right. You can see here, Shell, they had the old shed roof. This is the old rafter.
Oh, yeah,
in place.
the old rafter had come down, and on top of the wall here.
That's right. This is the old wall height, and they added a
little pony wall.
Pony wall on top, and this is a little bit unsafe because you can see if you look down the wall, it's bowing out. It's actually a hinge effect because the roof pushes the wall out when it gets a snow load on it.
And the part that really gets me, the pony wall studs don't even come over top, match up with those below.
Line up.
Wherever they happen to be, nail them home.
That's right. We'll take care of all that in the new renovation.
Well, they did put double plates in, though, by golly.
So it's fairly modern.
Well, you know, the building code today and having an engineer involved, I feel so much more comfortable, John. And listen, a building like this, what would it cost normally? By the time we're finished here, engineering costs?
It's less than 1% of your construction costs. So really, you know, you get a professional engineer, you get liability insurance. You know, it's well spent money.
Well, you've got all that peace of mind as well, because we want, again, I stress, we want this to be the best. But look at this corner here. No way could they've got any insulation into that corner whatsoever.
No.
And those 12-inch sheathing boards, you can see now the sawdust in amongst there, and look at the sawdust down here.
Wow.
And there's some that we didn't get. We vacuumed tons of sawdust out of this place. And the old windows here, double hungs.
Well, look at this window. There's nothing really even holding it in place anymore.
Well, you know, really, the interior, I guess, lath and plaster and drywall and the old sash balances here, I guess they were nailed in from the outside through the old brick mold as well.
Yeah, they must have been.
It's absolutely incredible. It's just a matter of, well, let's change something. Bang, go, they knock it out.
They just add on.
And the wall, you can see where it's used lumber, very likely from the barn, because it's painted white, and see a bit of yellow paint up here on the pony wall here. Oh, boy.
Wow.
Come on upstairs. I've got to show you something up there.
Okay.
Well, look at that. They used the old rafters for the ceiling joists. You can see the bird mouth there for the plate.
Yeah, they couldn't afford to throw away the old building materials, so they just kept reusing them.
Well, I guess that's recycling at that particular time.
Yeah.
Look at the roof sheeting here.
Yeah, you can see it's all broken up. You guys are going to have to replace the roof with new plywood.
Well, yeah, we want to get into at least half-inch plywood because we want a good, firm grip on our roofing shingles.
That's right.
Also, the old knob and tube wiring.
Wow. Look at this collar tie. It's supposed to be one solid piece holding the roof together, and they've got it built in 2 scrap pieces of lumber, barely nailed together.
Not properly. It's toe-nailed into place. That wouldn't hold anything if it ever came to an extra weight load, say, with snow.
That's right.
Well, I can tell you, we've got a real job. One thing nice about this whole project up here is the flooring looks beautiful, edge green fir. We'll certainly keep that in there and make it look great.
Don't want to waste that floor.
John, I want to thank you very, very much and look forward to working with you as the engineer in this project and getting it done the best way.
You bet.
Thanks a lot.
Thank you.
You bet.
Bye.